Hi guys, I hope that you're all doing well. In today's lesson, we'll do more practice questions related to the laws of exponents. So what if you have, let's say, 2x to the power 2 times 3x to the power 5? How do we solve this? You have 2 and 3. You don't have the same base. Remember, I told you guys that when you have the same base, you normally add the exponents because there's a division sign. But in this case, you have 2 and 3. So to solve this, you start with the coefficients. 2 and 3 are coefficients of these terms. Their coefficients are basically your values. If you have 2x to the power 3, 2 is a coefficient, okay? I'll keep reminding you guys throughout the video. So to solve this, you start by multiplying your coefficient or your values, the numbers. 2 times 3 is 6. Now let's move to our variables. I told you guys that the letters are called variables in mathematics. We have x to the power 2 and x to the power 5. Okay, I know that you guys are seeing 2x to the power 2 times 3x to the power 5, but we've already multiplied our values, the numbers. So we are basically left with x to the power 2 times x to the power 5. And to solve this, you guys know that when you have the same base, you add the exponents. In this case, you have x and x, so you write down our base, 2 and 5. So this is 2 plus 5. That's a multiplication sign. Please check whether it's a multiplication sign or division sign. Okay? Then we have x, 2 plus 5 is 7. So your answer is therefore x, 6, x to the power 7. That is how you solve this. If this was a bit confusing, that's okay. I'll do more examples throughout the video, ones that are related to this. But let's try the second example. Let's do 2 to the power 2 times x to the power 2. Outside a bracket, let's do to the power 3. Okay, now let's check. Inside a bracket, we have 2 and x. So this is not the same base. How do we solve this? The easiest way is to start with the first term, which is x to the power 2. Let's write down our x to the power 2. So this will be 2 times 3. As you guys see that there's a bracket there. Okay, so this is 2 times 3 times x. Let's write down our x. You have 2 times 3. So this is 2 times 3. Let's start with this part. This will be 2. 2 times 3 is 6 times, we have x, 2 times 3 is 6. Now let's simplify this part. When you punch this in your calculator or when you calculate it, you'll get 64. 2 to the power 6 is 64 times x to the power 6. 64 times x to the power 6 is equal to 64x to the power 6. That is how we solve this, okay? Now, what if we had number 3, a over b to the power 2? You guys know that you have to multiply your exponents with what's outside the bracket, okay? So this will be a, we have an invisible one there, 1 times 2, because it's 1 times 2. Over, we have b to the power 1 times 2. We have that. Let's start with a. 1 times 2 is 2 over b. 1 times 2 is 2. So our final answer is a to the power 2 divided by b to the power 2. If you had the same base, you could use some of the laws of exponents. For example, if you had, let's say, a to the power 2 over a to the power 2, we have the same base a and a. So this will be a 2 minus 2. This will be a to the power 0. And you know that anything raised to the power 0 is 1. But in this case, you don't have the same base. You have a and b. So that is your final answer. Now let's do number 4. Let's try 2 to the power 3 plus 200 to the power 0. How do you solve this? Let's check if you have the same base. You have 2 and 200. You definitely don't have the same base. And again, we have a plus. Now, it's not a multiplication or a division sign, so we cannot use the loss of exponents. So please check whether you have a multiplication or a division sign when introducing the loss of exponents. So to solve this, we can simplify this part. 2 to the power 3, when you punch it in a calculator, you should get 8 plus 200 to the power 0. Anything raised to the power 0 is 1. But if you're unsure, you can just punch 200 to the power 0 in a calculator. You will get 1. 8 plus 1 is 9. That is how we solve number 4. So for the fifth example, let's try 5 to the power 2 minus 9 to the power 3. You have 5 to the power 2 minus 9 to the power 3. 5 and 9, we definitely don't have the same base. Again, we have a minus sign. We don't have a plus or a division sign. Okay, so to solve this, we can simplify this part. 5 to the power 2 is 25. You can use your calculator to check. Minus 9 to the power 3 is 729. 25 minus 729, when you punch this in your calculator, your answer will be negative 704. Now let's try 6x to the power 4 times 2x to the power 3. We have 6 and 2. We don't have the same base, so we cannot use our loss of exponents here. So we'll just say 6 times 2. 6 times 2 is 12. Now let's move to our variables. We have x to the power 4 and x to the power 3. Let's write this on the side. X to the power 4 times x to the power 3. We have x and x. We have the same base. Okay, so we write down that base. Let's move to our exponents. We have 4 and 3. So this will be 4 plus 3, which is x to the power 7. So our final answer is 12x to the power 7. That is how we solve this. Let's try a similar example. What if we had 12a to the power 7 divided by 3a to the power 2? Let's check if we have the same base. You have 12 and 3. It's not the same base. So what can we do? We can calculate 12 divided by 3. Your answer will be 4. I can write this for you guys on the side. 12 divided by 3 is equal to 4. We wrote down our 4 there. Now let's move to our variables. You have a to the power 2 and a to the power 3. A to the power 7 and a to the power 2. Excuse me. Let's write this here. A to the power 7 divided by a to the power 2. We have the same base, a and a, so we can use our loss of exponents. We write down our base a, then 7 minus 2, because there's a division sign. 7 minus 2, which is a. 7 minus 2 is 5. So our final answer is 4a to the power 5. That is how we solve this. Now let's do another example. Let's try 8m to the power 5 divided by 2m to the power 3. 8 divided by 2, right? Because you don't have the same base. 8 divided by 2 is 4. So let's write down our 4 here. Let's move to our variables. We have m to the power 5 and m to the power 3. Okay, let's write this here. M to the power 5 divided by m to the power 3. We have m and m. We have the same base. So this will be, we write down our m. Let's move to our exponents. We have 5 and 3. This will be 5 minus 3. Therefore, m is equal to 2. Your final answer is therefore 4m to the power 2. Can you guys see how easy this is? You just need to practice your loss of exponents, and you need to have more practice questions. So let's try 5y to the power 2 times 4y to the power 6. How do we solve this? Let's check. We have 5 and 4. We don't have the same base. So on the side, let's write down 5 times 4. Your answer will be 20. So we write down our 20 here. Let's move to our variables. We have y to the power 2 and y to the power 6. Let's write this on the side. Y to the power 2 times y to the power 6. We have y and y, which is the same base. Let's write down our base. We have 2 and 6. This is 2 plus 6, because we have an x in between. 2 plus 6, which is y to the power 8. So our final answer is 20y to the power 8. Okay, now let's do the last example. Let's try 18p to the power 9 divided by 6p to the power 4. How do we solve this? We have 18 and 6. That is not the same base. So on the side, we can calculate 18 divided by 6, which is 3. Let's write down our 3 here. Let's move to our variables. We have p to the power 9 and p to the power 4. P to the power 9 divided by p to the power 4. P and p, we have the same base. Let's write it down. 9 and 4, this is 9 minus 4 to the power 5. Your final answer is therefore 3p to the power 5. Let's try x to the power a times x to the power b. How do we solve this? We check our base. We have x and x. We have the same base. So this is x. Let's move to the exponents. We have a and b. So this is a plus b. And that is your final answer. There isn't much that you can do here. You can't really calculate a plus b. Let's try x to the power a over x to the power b. How do we solve this? We check whether you have the same base. You have x and x. So this is x. We have a and b. So this is a minus b. And that is your final answer. So what if we had p to the power m divided by p to the power p? How do we solve this? We have p and p, which is the same base. Let's write down that base. And let's move to the exponents. We have m and p. This will be m minus p. And that is your final answer. And lastly, let's try x to the power 2 divided by x to the power 2. How do we solve this? We'll say x, we have x and x, which is we have the same base. Let's write down that base. Let's move to the exponents. We have 2 and 2. So this is 2 minus 2, which is x. 2 minus 2 is 0. And anything raised to the power 0 is 1. And that is how you simplify using the laws of exponents. Thank you guys for watching. Please like and subscribe. I'll do more examples.